Imagine a completely normal day. You reach into your pocket, expecting to find some lint or a forgotten coin, but instead, you find a black hole. Not a supermassive one, like the terrifying monster at the center of our galaxy, but a tiny one, exactly the size of a standard coin. What would happen? Would it just sit there peacefully? Would it suck you in? Or would it destroy the entire planet? Spoiler alert, your day is about to get significantly worse. To understand the sheer magnitude of this disaster, we need to understand what a black hole actually is. A black hole isn't just an empty hole in space. It is a tremendous amount of matter packed into a very small area. Think of a black hole not by its physical size, but by its sheer mass. To make a black hole the size of a coin, measuring roughly 20 millimeters across, you would need to crush something incredibly massive down to that exact tiny dimension. How massive? You would need to take the mass of the entire Earth, including all its oceans and continents, and multiply it by roughly the mass of another Earth. Yes, a coin-sized black hole has roughly the same mass as our planet. So, this Earth-mass coin is currently sitting right inside your pocket. The very first thing you would notice is the gravity. Gravity depends on two main factors, mass and distance. Because this black hole has the mass of an entire rocky planet, and it is literally inches from your leg, the gravitational pull you experience would be billions of times stronger than Earth's gravity. In a fraction of a millisecond, your body wouldn't just be pulled down, it would be violently stretched and shredded apart. Your atoms would be stretched into a thin stream of subatomic spaghetti and ripped straight into the dark, glowing event horizon. You are entirely gone. Poof. Vaporized into the cosmic abyss. But the tiny, terrifying, coin-sized black hole remains hovering exactly where your pocket was. Welcome to the ultimate cosmic disaster. It is time to explore the sheer scale of planetary destruction. What if a black hole appeared in your pocket? Let us pause for a moment. You might think, because it is so incredibly small, it would just fall through the ground like a heavy dropped pebble. But remember the density problem we discussed earlier. This tiny glowing sphere possesses the massive gravity of an entire rocky planet. Its gravitational pull is not just strong, it is completely world-breaking. The ground directly beneath the black hole does not just simply crack, it violently shatters into microscopic dust. The immense gravity rips the bedrock apart, pulling billions of tons of dirt straight up into the air. Because the black hole is being pulled by the Earth's gravity, and the Earth is being pulled by the black hole, they begin a deadly dance. The coin-sized singularity begins to free fall straight down, plunging deep into the crust at a terrifying speed, accelerating towards the center of the Earth. But it does not just fall cleanly through the rock. It violently consumes absolutely everything in its path, creating a superheated tunnel of destruction. Solid rock, ancient fossils, underground water reserves, and glowing magma. It all gets ruthlessly swallowed by the tiny, glowing orange sphere. As billions of tons of matter fall into the microscopic event horizon, it gets incredibly compressed and heats up hotter than the sun. This superheated, swirling matter forms a blindingly bright accretion disk around the black hole, emitting lethal levels of intense X-ray radiation. This radiation is so incredibly powerful that it instantly vaporizes the rock, creating a massive glowing plasma bubble deep beneath the surface. The black hole continues its descent, eating its way through the dense mantle, growing slightly larger and significantly heavier with every mile. Within minutes, the tiny cosmic monster reaches the Earth's solid iron core. But it doesn't stop there. It swings past the center like a pendulum. Gravity doesn't just stop at the center. The black hole's immense momentum carries it all the way through the other side of the planet. It bursts violently through the mantle and the crust on the opposite side of the Earth, shooting straight up into the atmosphere. For a brief, terrifying moment, it hovers in the sky before Earth's gravity pulls it right back down again into the crater. This creates a catastrophic cosmic pendulum. Back and forth it swings, plunging through the center of the Earth over and over again. With every single pass through the planet, the black hole consumes billions of tons of rock, magma, and solid iron. And as it eats, it grows. Its event horizon expands, and its gravitational pull becomes even more devastatingly powerful. The structural integrity of our planet is completely compromised. The Earth is literally being hollowed out from the inside like a rotten apple. On the surface, the consequences are absolutely apocalyptic. Massive, unprecedented earthquakes shatter every single tectonic plate across the globe simultaneously. Cities crumble into dust in seconds. Giant fissures open up in the ground, swallowing entire mountain ranges and forests whole. The superheated plasma, created by the black hole's intense radiation, forces its way up from the core to the fragile surface. Thousands of supervolcanoes erupt all at once, blocking out the sun with thick, toxic ash and raining glowing fire everywhere. The oceans begin to boil instantly as the immense heat from the exposed planetary core meets the cold water. Massive plumes of superheated steam rise into the atmosphere, creating violent hyper-hurricanes that completely scour the remaining shattered land masses. The Earth is no longer a habitable blue dot. It is a fractured, glowing ball of magma, steam, and cosmic despair. And the worst part? The black hole hasn't even finished its meal. The final collapse of our world is just about to begin. The final stage of this planetary disaster is the implosion. The planet begins to literally collapse in on itself, folding inward toward its new center. With the core entirely devoured, there is nothing left inside to support the immense weight of the outer rocky layers. The massive tectonic plates, entire continents, and the dried-up ocean beds fold inward, crumbling into the tiny gravitational abyss. As the matter violently compresses, the atmosphere itself ignites in a blinding, superheated flash of expanding cosmic plasma. The black hole has settled exactly at the Earth's center, eating our world from the inside out like a terrifying cosmic parasite. In a surprisingly short amount of time, perhaps just a few terrifying hours, the Earth as we know it completely ceases to exist. Where a vibrant blue and green marble once proudly orbited the sun, there is now only a swirling graveyard of debris. A brightly glowing, superheated accretion disk of crushed rock, magma, and metal violently circles a pitch-black void. And how big is this new black hole that just swallowed an entire world? Surprisingly, it is not much bigger than before. Because it absorbed exactly one Earth mass on top of its original Earth mass, its event horizon has only doubled in diameter. Congratulations! You have successfully upgraded a 20mm coin into a 40mm golf ball. A very, very heavy golf ball. This tiny golf ball-sized singularity now weighs exactly as much as 2 entire Earths, spinning silently in the dark cosmic void. During the final explosive collapse, some fragments of the planet's outer crust were violently flung outward, escaping the event horizon. These lucky surviving fragments now form a miniature, chaotic asteroid belt, orbiting the tiny singularity in the cold vacuum of space. But the destruction of Earth isn't the end of the story.
Guys?
We have a very confused neighbor nearby to check on. The moon is now suddenly orbiting a tiny invisible point that weighs exactly twice as much as the beautiful blue planet it used to know. Because this central mass has suddenly doubled in a matter of hours, the moon's delicate orbital balance is completely thrown into immediate cosmic chaos. It gets violently yanked out of its stable circular path and is aggressively pulled into a highly erratic, spiraling orbit much closer to the singularity. As our poor rocky neighbor is dragged closer and closer to the black hole, it begins to experience extreme gravitational stretching, known as tidal forces. The side of the moon facing the black hole is pulled significantly harder than the far side, causing the entire moon to bulge and warp. Within days, the structural integrity of the moon completely fails. It is violently ripped apart into billions of giant, tumbling rocky fragments. These fragments spread out along the orbital path, eventually forming a magnificent, glowing ring of debris around the tiny black hole and its accretion disk. So
Okay,
Earth is a
Earth is a
superheated
blender.
cosmic
Check.
blender,
And the
moon
is
is now a
ring.
beautiful
Check.
rock ring.
Now,
But what
where
about
to
the rest
next?
of the solar system? Surprisingly, to Mars, Jupiter, and the mighty Sun, this dramatic local apocalypse goes completely unnoticed. Everything else just keeps on orbiting normally. Remember our gravity equation? From millions of miles away, the gravitational pull of our new, tiny black hole is exactly the same as the old Earth. Mars doesn't feel a stronger pull. Venus isn't sucked in. The delicate orbits of the outer gas giants remain perfectly stable and undisturbed. The sun continues to shine, completely oblivious to the fact that its third rocky planet has been replaced by a golf ball-sized cosmic void. It is a rather humbling thought. Our entire world, our history, and our moon could be completely destroyed, and the wider universe wouldn't even blink. But wait, let us rewind for a second. There is actually a massive fundamental flaw in this entire dramatic apocalyptic scenario. What if the black hole that appeared in your pocket didn't have the mass of the Earth, but just the tiny mass of an everyday coin? If you took a normal everyday coin and magically crushed it down into a black hole, it would not have the mass of a planet. It would still just weigh 5 grams. Because it has so little mass, its physical size would be incomprehensibly microscopic, far smaller than a single atom. In this subatomic realm, gravity takes a back seat. Instead, a bizarre and fascinating quantum phenomenon called Hawking radiation kicks into high gear. Named after the brilliant physicist Stephen Hawking, this theory states that black holes aren't completely black. They slowly leak energy back into the universe over time. And here is the catch. The smaller a black hole is, the hotter it gets, and the faster it radiates this energy away. A supermassive black hole takes billions of years to evaporate. But our microscopic 5-gram singularity, it is so unimaginably hot that it evaporates almost instantly. In a tiny fraction of a single second, the entire mass of that 5-gram coin is violently converted into pure, unadulterated energy. So, let us rewind our scenario back to a normal Tuesday. You are standing in the park, and that 5-gram black hole appears in your pocket. This time, you don't get stretched into a noodle. The Earth doesn't get hollowed out. In fact, gravity barely has time to pull on your leg. Before you even register that something is wrong, the microscopic black hole flashes with a blinding, intensely hot blue light and completely evaporates. But remember Einstein's famous equation: energy equals mass times the speed of light squared. Converting 5 grams of solid matter into pure energy is catastrophic. The instantaneous release of that energy is equivalent to a massive nuclear detonation, roughly 3 times more powerful than the bomb dropped on Hiroshima. A brilliant, colorful explosion of superheated plasma instantly vaporizes you, the park, and everything within a several-mile radius in a spectacular flash of light. A massive, perfectly circular crater is left behind, glowing with residual heat. The city is completely wiped off the map, leaving a smoking ruin. So, instead of destroying the entire solar system, you just accidentally nuked your own hometown. I suppose that is a slight improvement, relatively speaking. So, let us summarize. If a theoretical coin-sized black hole suddenly appears out of nowhere inside your pocket, you either trigger the slow, agonizing, and unstoppable gravitational collapse of our entire rocky planet, or you get instantly vaporized in a spectacular, blindingly hot quantum explosion that wipes out your city. Either way you look at it, it is objectively a terrible Tuesday. You should probably just stay in bed. But beyond the dark comedy, these two absurd, apocalyptic scenarios serve as a powerful and deeply humbling reminder of the sheer scale we live in. They are a reminder of the sheer, terrifying and awe-inspiring power of the vast cosmos that surrounds us. Our universe is a wild, untamed frontier, governed by strict, unyielding physical laws that we are just beginning to understand. These extreme, absolute forces of gravity and quantum mechanics do not care about our daily lives or our personal problems. They do not care about our sprawling cities, our fragile history, our politics, or what we keep in our pockets. And out there in the freezing dark of space, there are millions of real, actual black holes lurking unseen. These are cosmic monsters, born from the explosive dying breaths of giant stars, wandering silently through the Milky Way galaxy. Some are supermassive titans, billions of times heavier than our sun, sitting in galactic centers, devouring entire star systems. But thankfully for us, space is incredibly, unfathomably empty. The distances between objects are almost impossible for human brains to grasp. The closest known black hole to Earth, a sleeper called Gaia BH1, is over 1,500 light-years away. It is safely tucked away in the cosmic distance, completely harmless to our fragile, beautiful blue dot spinning in the void. So the next time you reach into your pocket and pull out a regular, boring 5-gram coin, take a moment to really appreciate it. Appreciate that it is made of normal matter, bound by normal gravity, and completely incapable of destroying the entire solar system. We live on a tiny, fragile island in a terrifyingly vast, chaotic, and largely indifferent universe. But instead of being paralyzed by the sheer, incomprehensible scale of these cosmic monsters lurking in the dark, we should be incredibly proud. Because from this tiny rock, we have evolved the incredible ability to look up. We have learned to do the math, to build the telescopes, and to actually understand the terrifying beauty of the cosmos. We can simulate black holes, calculate quantum evaporation, and explore the furthest reaches of the universe simply by using our minds. And that conscious curiosity, in itself, is a phenomenon far more wondrous and rare than any singularity. So, keep your pockets empty of collapsed stars. Remember to look up at the night sky and never stop asking questions. If you want to continue exploring the terrifying and beautiful universe with us every single month, make sure to hit that subscribe button and ring the bell so you never miss a cosmic disaster. We spend hundreds of hours researching, writing, and animating every single detail to bring these complex scientific videos to life. If you want to support our mission to make science look beautiful and accessible, consider joining our incredible Patreon community. You get exclusive behind-the-scenes access, high-resolution scientific posters, and cute bird wallpapers for your phone and desktop. Click the video on the screen to see what happens if the sun suddenly disappears. Stay curious, and thanks for watching. Would it suck you in, or would it destroy the entire planet? Spoiler alert, your day is about to get significantly worse.